we'll basically just let them finish. We'll run both of them and see how they compare. If you're watching this video, there is a good chance that you're familiar with the current sentiment around the Llama-4 release, which is that it is not so good. I am not personally going to comment on my opinion of the model because 1, I can't run it locally, and 2, I haven't done enough testing with it to really give a yes or no answer towards its performance. However, something I want to do is compare it to a previous version of Llama that was pretty widely regarded as a good model throughout the community, and that is Llama 3.3 70B. So what we're going to be doing today is basically comparing the new Llama-4 model as is available to us in this meta.ai online interface. Now, unfortunately, if we go into settings here and click change your model, it doesn't tell us the specific version of the Llama-4 model that we are being served here. I would go ahead and assume that it is probably Maverick, but again, without seeing that in writing for sure, I can't say with any certainty. There are 2 things I would like to give as scientific disclaimers before we jump into this. The first is that this is not a fair or direct one-to-one comparison. These models are architecturally different in that the Llama-4 models are MOE models, so they have less activated parameters per inquiry that they're answering as opposed to this 3.3 70B model. In addition to that, the 70B model that I am running is the default Ollama Q4KM quantization, and it is running on the desktop behind me using an open web UI web interface that it's being served through. So this is kind of like if we were going to be comparing 2 3D printers, except one was a resin printer and the other was an FDM printer or something that just prints from a spool of plastic. They're both printers, but their methodologies of actually printing the part are different. So think of this more as a vibe test. Following that, the only other thing I really want to bring up is that 1, Llama-4 is obviously multimodal, so it can take images as input and images as output, etc. Llama 3.3 70B is a text-only model, so we can't actually do any image testing with it, so we will be stuck with just kind of text-based prompts and coding and things of that sort. I do find one thing interesting here. Now, again, I don't want to speak to my opinion or impression of this model right now, at least until I do this test. But if we see the Llama-4 page right here on Hugging Face, we can see the training data includes the original training data that was also listed for Llama 3.3 70B, which was a new mix of publicly available online data. But for Llama-4, we have that. However, we're also including information from Meta's products and services, publicly shared posts from Instagram, Facebook, and people's interactions with Meta AI, which basically means if you have Facebook Messenger or Messenger, whatever it's called now, you can actually chat with the AI in there as well. So this would be likely drawing from folks' actual messages with that AI, which, I mean, seeing this, I just feel like Llama-4 is going to try to sign me up for its course to learn how to be a dropshipper. But I don't know. Again, the quality of some of these data sources could definitely be called into question just in terms of, I think, the default behavior that one sees on Instagram or Facebook. But I am kind of getting a bit verbose, so let's hop in. The first thing I want to do is not my coding game test, but it is actually just a story test. So I did kind of come up with a prompt here. I had a little help from Claude, but I feel that it needed a little bit of more humor injected into it. So we are going to do a simple creative writing task, and that is going to be to write a short story about a robot discovering arousal. Exactly 3 paragraphs and a surprise ending. I don't know what that entails, but we are going to see how either model does. All right, so both of the responses are now side by side. On the left right here, we have Llama 3.3 70B, and on the right here, we have some variant of a Llama-4 model. Now, I do find it very interesting that both of these models named the robot the same thing, which was Zeta or Zeta. Now, I do have to say, again, this is a subjective test, so you may pause this and read either one of these and be like, hey, that one's way better, while someone else may have a totally different kind of response to this. But I do have to say it is a bit weird because the 3.3 was a little funnier because it basically seems to have become kind of aroused by a recording of Chopin's Nocturne in E-flat major, and then they basically found that it was a musical genius which tied into its arousal, which make of that, I suppose, what you will. In Llama-4 here, the actual kind of surprise ending, I have to say, was not as good. And I'm going to be honest, again, it's subjective, but okay, it became a being of light and found a digital state of nirvana. Like, that's cool, but it's not really relating to arousal, I would suppose one says. While the one Llama 3.3 did is kind of, I don't know. Again, it's subjective, and we're just kind of vibe testing the persona of either of these models. So that is going to wrap the first test here, which was an interesting story test, I suppose one could say. Now, the next thing we're basically going to do is just jump right into a Python game development test, where if you've watched any of my other videos, you'll be familiar with this. I just like to have them make a retro synthwave style Python game using no external dependencies, with the end goal to be creating a functional game regardless of how intricate the actual game is. So we'll just go ahead and run that one right there on the local machine, and then I will run this one right here on the online interface. Obviously, it's going to be faster from the Llama-4 online one, as it's not being locally hosted, but we'll basically just let them finish. We'll run both of them and see how they compare. So I do find this a little weird. 3.3 was like, here's it with Pygame. Haha, just kidding. I guess it injected humor there, which is, I don't quite know what to say to that. So let's just go ahead and run this one first. It does seem like the one that 3.3 came up with is a text-only based, where you can just type collect to collect coins or run to avoid obstacles. I'm not entirely sure how this works, but we're basically just going to go ahead and try it. All right, so this is my first attempt at running the game generated by Llama-3. Again, first test is to make sure the games actually run with no errors. What do you want to do? Type collect to collect coins and run to avoid obstacles. Well, I think I'd like to collect coins, which I collected a space coin. All right. Coins 1, health 100. I think I'm going to run. I successfully avoided it. I'm just going to keep running. Okay, so if you run and you can't avoid an alien, it takes your coins. Oh no, it takes... Okay, well, the game works. It's text-based, but it did keep with not using any external dependencies. So I am just going to go ahead and kind of clear that, and we'll basically just go ahead and do the same thing, except now we'll try the game that Llama-4 generated, which, just based off looking at the code, it does seem like this will be a little more interactive. Okay, so A or D? Okay, yeah, I was totally wrong about this being more interactive, but the asterisk, or the caret symbol, I apologize. You know, I should probably move left and right. Enemies move across the screen. So I need to avoid the enemies represented by the X's that move across the screen. If an enemy hits me, then the game ends. All right, I'm just gonna spam click. Oh, okay, and it seems that I lost. Game over. All right. Overall, I would say that this is kind of a toss-up because they both performed adequately. They both listened in that they didn't use any external dependencies, so neither of them used Pygame or really put in any graphical element of this. Llama 3.3 went with more of a kind of story role-playing type game, I suppose you could say, and 4 went with a kind of retro terminal style game. I would say, again, that was both a success, and this is obviously subjective. However, again, yeah, I'm not even going to inject any of my personal opinion into this, as I want this to be more of a kind of you make your own call after seeing what we do here. The next thing we're going to do is basically see how well these things do in seeing if they can find a bug. So what I have right here is that I've forgotten how to start. Okay, good. So this is a C# script from one of my robots that I made. It's pretty old at this point, but basically it just handles like the text-to-speech, speech-to-text, OpenAI, like API call. You can see it still shows GPT-3 Turbo here, so it's 3.5, so it's pretty slow. But basically, I just want to mess one thing up, and I'm going to ask it and say, hey, this is not actually speaking anything. Do you think you could help me kind of diagnose the problem here? So I'm just going to mess that up. So basically, TTS button click there would break it. It should be dot button click. So ignore kind of the meaning of that, and I will just say, in this script, text-to-speech isn't working. Could you please help me troubleshoot this bug. Okay, so this didn't necessarily get it right. It just gave me some potential issues and what may actually be happening. Ensure that the method is being called correctly. It is not correctly being executed, so adding a debug log inside the method would kind of help point us towards the correction of this issue. However, at the same time, it doesn't actually fix the issue, which is kind of what we wanted to happen here. So basically, all I'm going to do now is just go ahead and copy paste this prompt that I sent it right here with the buggy code as well as the initial prompt, and just paste this one in right here to 3.3 latest, and we will basically see how it responds to this. So neither of them really got the actual issue, which was like, hey, you need to add a period next to the TTS dot button click. However, they both kind of went about doing the same thing where they suggested some potential issues, and then they actually went ahead and added some debug statements to our script to basically find out where the issue has actually occurred. So neither of them got it right, I would say, but you know what I'm going to do? And this isn't something I'll let this finish. This one is rewriting the entire script. And again, left is Llama-3.3 70B and right is Llama-4. All right, so neither of them correctly identified the issue, but they both provided some decently valuable troubleshooting steps, as well as some appendages to the scripts to actually help us debug the issue. What I am going to do, and I didn't expect to do this, I'm going to go to ChatGPT, and let's just take a look at whether or not O3 mini high will be able to kind of solve this for us. So let's just paste this in. We'll see what this says. All right, so a SOTA or state-of-the-art closed source model got it, which I suppose would be expected. Again, you know, I do have to say, I kind of like the bug chasing test for these scripts because I think it's interesting in a way to actually bring out some of the nuances of the different models and things like that. I don't really think I had any other tests planned for these. Again, I really just kind of wanted to give a visual and more side-by-side comparison of the older 3.3 70B quantized model running locally versus the Llama-4 model running through the Meta AI website. And again, I am opting to actually test this model here on Meta's own website because in new releases, sometimes parameters or things like that could perhaps be misconfigured where they're accessible. So I figure I have the best chance of getting the best configured model on their own platform. With that, that really is going to conclude this. I do have to say, regardless of what you take from this, 3.3 is 70B is definitely holding its own, and for a local model, it is awesome. That brings me into, I think, my main frustration with the Llama-4 releases, and that is that I can't run them locally. Again, it is a freely released model, so you're like, no one's going to force you to use it. But I think that some of the negativity that I have seen or read about online definitely comes from the fact that even though these are MOE models with fewer activated parameters per request, the actual resources needed to run the model are high because of their architecture and the fact that even in the smallest variant, it's like 109 billion parameter model. So unfortunately, it is more resource intensive, and even with a system like the one behind me with two 3090 Ti's in it, I'm not capable of running this locally. There will obviously hopefully be quantizations and things like that, but it is just frustrating. And honestly, it seems like unified memory is the way to go. I saw an Apple community MLX quant for this pop up last night, and I was looking at Max online, which you know, it is what it is. So overall, that is going to conclude this. I hope that this provided some level of educational or subjective judgment between these models' value. If you have any questions, please feel free to let me know. Honestly, I really actually had a ton of fun filming this and playing with this. Side by side like this is not something I've done before. I apologize if my hand is very animated. I must be excited. But this was fun, and this might be something that I try to do more often, as I think it gives cool insight into model experience. So it's going to wrap it, and thanks for watching.